Aloha and welcome to our video on cloud formation. In this video, we will describe what happens to air when it's compressed or allowed to expand. We'll list the four mechanisms that cause air to rise. We'll compare and contrast movements of stable and unstable air, and then we'll describe the conditions in the air that favor condensation of water. In this slide, what we're looking at is adiabatic heating and cooling in the atmosphere. And what that means is that we're changing the temperature without the use of heat. So we're not heating it up, we're not cooling it off, we're changing the temperature without any heat energy transfer. And the way that we accomplish this is through pressure. If we increase the pressure, what that does is that puts the gases all closer together. The little atoms and the molecules are closer. They're bumping into each other. There's a little bit of friction, and we generate heat that way. If we decrease the pressure, then what we notice is now those collisions are happening less often, so it's actually going to cool off a little bit. There's less frictional heating. And we can kind of see that as we go up higher, we notice there's less air pressure. So what that means is that the temperature is going to drop as we are raising up higher and releasing the pressure. So we'll notice that if we have our water that's evaporating, as we go up, it's going to get cooler and cooler and cooler. So we'll have a condensation level here. Notice here we have just the water vapor. Up here is where we're going to start getting condensation, and that's where you're going to see these cloud formations going on there. So if we move on, what we're going to look at here is we have our four different pictures of how we can get lifting in the atmosphere. So if you recall, that lifting is going to come up, it's going to cool it off, we're going to get condensation, and that's how we get our cloud formation to occur. So through lifting, we get cloud formation. The first one we have is orographic lifting. And orographic lifting is geography based. What that basically means is we have air blowing this way, it hits a mountain, and as it hits a mountain, it's going to cause it to lift up. And as it lifts up, we're going to get condensation. We're getting cloud development that you can see over here. A lot of times you'll get a lot of precipitation over here. And then on the other side, we have what we call a Rainshadow Desert. So here in Vegas, if you take a look at the mountains to our west, you'll a lot of times see clouds forming up over the mountains, and it's raining in the mountains, but we don't get a lot of rain here because we're in that rain shadow of a desert. The same is true if you look to the east over at Lake Mead. You'll see that we have this area where these clouds, the wind's blowing across, it hits the mountains there, it's forced up, we're going to get cloud development over Lake Mead as well. So orographic is where we have cloud formation over the mountains, and that's because we have the wind blowing over there. As it goes up, the pressure decreases and we get condensation. Now there's other types that we can get this as well, this lifting. One is convergence. If we have winds blowing in two opposite directions, when they collide, they can't go down into the earth. So instead what we're going to see is lifting occurring this way. So if we have winds being funneled into an area, or if we have winds from two different directions blowing into each other, that's where we'll see this convergence and you'll see the cloud formation. We have frontal wedging occurring here, and notice we have cold air here and warm air. So our cold air here and our warm air is here. As the warm air is blowing towards the cold air, there's this density line here, this pinocline, like we talked about with the oceans a little bit. So we have a denser cold air and a less dense warm air. That warm air is going to blow right up the edge of this cold air, and we're going to get this lifting, and that's going to cause condensation and ultimately precipitation, and that's how we'll get this. And we'll talk more about this when we talk about fronts a little later on in this term. And then finally, we have these localized convective lifting. And what that means is that we have this variation of the surface. A road's going to heat up a lot faster than the grass will here. And what we'll notice is because our heat here and is being released off, we get these lifting convection currents that are going here. And that's going to cause our lifting, and that'll ultimately lead to some cloud development. So that's four different ways that we can get lifting in the atmosphere. And remember, the lifting is important because as it goes up, it cools off, and that allows condensation to occur, and that's how we develop our clouds. And if we get enough lifting and enough condensation, we can get precipitation. So sometimes you hear the weatherman talk about whether we have stable or unstable air. And what that means is it's kind of telling us if the air that we have is going to be stable, it's not going to be rapidly trying to move, or unstable. When we look at the difference, you'll understand that. Now, to understand this, we have to understand a couple things. First, we have warm air, and warm air means that the molecules are going to be moving faster, they're going to be spread out a little bit more, and the net result is it's going to be less dense air. So it is going to want to rise. We can also have cool air, And cool air, the molecules are going to be a little bit closer together. They don't move as much so that they can hang out kind of closer to each other like so. And that means that it is more dense. So it's going to be like a heavier air and it's going to want to sink. So our cool air wants to sink. Our warm air wants to rise. So when we look at stable air, notice we have warm air up here and we have our cool air down there. Our cool air wants to sink, our warm air wants to rise. We don't have any mixing. That's why we say it's stable. A result of this is in stable air is we generally tend to get stratus cloud formation. Okay, it's still not a lot of movement. Now we can have unstable air, and notice here we have this cool air above that really wants to be sinking, and we have this warm air below that truly wants to be rising. So we have a lot of lifting and going on and crazy stuff, and when we have unstable air we get this lifting, and notice we get cumulus cloud formation, and that's because this warm air is trying to rise up. Warm air also holds more moisture, so as it's interacting with that cold air, you're going to get that condensation and ultimately precipitation. We can also have this last condition here of conditionally stable. Notice we have the warm here, we have the cool here, so that tells us it's stable, but now we have some heating going on. And if we have heating going on, it's going to warm the air around it, and that air is going to want to rise. And as it does so, we're going to see some lifting there. We can see some mixing. So we'll see that it's kind of stable, but not totally stable. So that would be conditionally stable for us. So now you can understand when they say stable air, what they're talking about are unstable air. And we have clues. If you go out and see stratus clouds, you're going to say it's stable air. If we see cumulus clouds forming, then we're going to see unstable air. Now, how do we get this condensation to occur? Most of it, we're going to talk about a condensation nucleus. So we're going to have something up in the atmosphere, like dust, for instance, is a really good one. And what that's going to do is that's going to allow this water vapor to condense on it. Remember that if I take my nice cold glass of water and set it on the counter, the glass of water is where the condensation is occurring. There has to be some kind of a surface for it to happen to. It doesn't just randomly occur. So we have these condensation nuclei, and they're going to be very tiny. Notice from there, we can have a typical cloud droplet, and you're going to see it's there. It's just going to be water that's wrapped around this condensation nucleus. We can have a larger cloud droplet, and then down below you see just the very tip top of what we would see as being our raindrop. So you can see how small these condensation nuclei are going to be. One of the interesting things is we look here, I said it was dust, it can also be smoke. So as we have smoke from our airplane engines going on, it's being ejected out of the back of the engine, that smoke can work as a condensation nuclei, and that's how we develop our contrails here, which you can see behind the jet. Okay, so that's it for our video. As always, this was just a quick overview. Good luck with your lesson and your quizzes, and we'll see you in the next video.